Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will sketch the function below, which is f of x is equal to 2x to the power of 2 divided by x to the power of 2 minus 1. To do that, we'll study its domain, its x and y intercept, its symmetry if it exists, the asymptote when it is increasing, decreasing, the concativity, and the point of inflection. So let's start by its domain. I know this function is discontinued when the denominator is equal to 0. That means when x squared minus 1 is equal to 0. So x squared should be different than 1. So x should be different than plus or minus square root of 1 is 1. So my domain is between minus infinity to minus 1 union minus 1 to plus 1 excluded union 1 to plus infinity. So if it is only discontinued at minus 1 and 1. The second thing that I will study is the x and y intercept. So the x-intercept, that means x is equal to what when y is equal to 0. So if y is equal to 0, which is 2x squared divided by x squared minus 1 is equal to 0, I do cross multiplication here. I would have 2x squared equal to 0. That means x is equal to 0. So I know x is equal to 0. It's a point on my, it's my x-intercept. And the y-intercept, y is equal what when x is equal to 0. If I replace here x is equal to 0, I would have y is equal to 0. So I know my graph would pass by 0, 0. Now let's study the asymptote. I know x can never be equal plus or minus 1. So x equal to 1 and x equal to minus 1 are vertical asymptote. Because if x equal 1 or x equal to minus 1, my denominator is equal to 0 and I cannot have a denominator of 0. To find the horizontal asymptote, I have to study the limit when x goes to infinity of my f of x, which is 2x squared divided by x squared minus 1. It is equal limit when x goes to infinity of 2x squared divided, I can factor out x squared in the denominator. I would have 1 minus 1 over x squared. So x squared and x squared, I can simplify it. And when x goes to infinity, 1 over x squared goes to 0. So this would be equal to 2 divided by 1, which is 2. So I know I have y equal to is a horizontal asymptote. So let's highlight them. I know my vertical asymptote are these and my horizontal asymptote are here. So now I want to study when it is increasing and when it is decreasing. By doing so, I have to find f prime of x. I know that f of x is equal to x squared divided by x squared minus 1. So I can take which is equal to u divided by v, and I can take 2x squared as my u, and I will take my v as x squared minus 1, and my formula is u prime v, which is 4x times x squared minus 1, because if u is 2x to the power of 2, my u prime is 4x, minus u, which is 2x squared v prime, multiplied by 2x, because my v is equal x squared minus 1, divided by v squared, which is x squared minus 1 to the power of 2. So let's develop it. F prime of x is equal 4x to the power of 3 minus 4x minus 4x to the power of 3 divided by x square minus 1 square. So I have here 4x to the power of 3 minus 4x to the power of 3. That would go out. So f prime of x is equal minus 4x divided by x square minus 1 square. And f prime of x is equal to 0. F prime of x is equal to 0 when x is equal to 0. Because the only way I can do this is equal to 0 cross multiplication. I have minus 4x is equal to 0. That means x is equal to 0. So I know if x is equal to 0, f of x is equal to 0. We just find it here when I was studying my y-intercept. So I know 0 is a critical point. Why? X is equal to 0 is a critical point. So if I want to study where it increases, where it decreases, I have to draw my famous table. I know my domain is minus infinity to plus infinity, but I cannot have minus 1, and I cannot have plus 1, and I have 0 as a critical point. So this is f prime of x, and this is f of x. So between minus infinity and minus 1, I can take any number between minus infinity and minus 1. Let's take minus 2. So, and I replace it in f prime of x. If I put minus 2 here, I replace x by minus 2, I would have minus 4 times minus 2 is plus 8. And the denominator is always positive because it is to the power of 2. So minus 8 is negative. So my function goes, is positive, plus 8. Minus 2 times minus 4 is plus 8. And plus divided by plus is plus. So I know it's going up. Between minus 1 and 0, I will take minus 0.5. And minus 0.5 times 4 is plus 2. Divided by a positive number, it's always positive. Now between 0 and plus 1, I will take 0.5. 0.5 times minus 4 is negative, divided by a positive number, so it is negative. So I know here I have a maximum at that point. And between minus 1 and plus infinity, I will take 2. 2 times minus 4 is minus 8. It is negative, so it's keep on going down. And if x is equal to 0, we said f of x is equal to 0. So I have my 0, 0 is a maximum. It can be a relative maximum or absolute maximum. I don't know yet. So now let's study its concativity and point of inflection. To do that, I need f prime of x, f second of x. I know f prime of x, we said it's equal minus 4 x divided by x square minus 1 square. And f second of x, I can take, this is my v, and this is my u, and this is equal u divided by v. So my f prime of x is equal u prime v, which is u prime, what happened? U prime is minus 4 times v times x square minus 1 square minus u v prime. My u is minus 4x, and my v prime is 2 times x square minus 1 multiplied by the derivative of x square is minus times 2x divided by v square. I already have it to the power of 2, so it becomes to the power of 4. X square minus 1 to the power of 4. Now let's calculate my f second of x. F second of x is equal minus 4. X square minus 1 square is x to the power of 4 minus 2x square plus 1. And this minus times minus is plus. 4 times 2 is 8, times 2x is 16x square. So I have plus 16x square multiplied by x square minus 1, and all that divided by x square minus 1 to the power of 4. So let's develop my f second of x, keep on developing it. F second of x is equal, now I multiply minus 4 by all my parentheses, it becomes minus 4x to the power of 4 plus 8 to the power x to the power of 2 minus 4 plus 16x to the power of 4 minus 16x to the power of 2, and all that is x squared minus 1 to the power of 4. And let's simplify it. I have 16x to the power of 4 minus 4x to the power of 4 is 12x to the power of 4. I have minus 16x2 plus 8x2, it is minus 8x to the power of 2, and I have the minus 4, I keep it, and I divide by x squared minus 1 to the power of 4. Now I can make my numerator as a quadratic function by saying let y equal x to the power of 2. So my f second of x is equal 12y squared minus 8y minus 4 divided by x squared minus 1 to the power of 4. And now let's find my y1 and y2. I'm sure you remember from previous year, for a quadratic function, my y is equal minus b plus or minus square root of b squared minus 4ac divided by 2a. And my a is equal to 12, my b is equal to minus 8, and my c is equal to minus 4. So y is equal minus b, it's 8, plus or minus square root of minus 8 squared is 64, minus 4 times 12, my a, and my c is equal minus 4, we said, divided by 2a. So my y is equal 8 plus or minus square root of 64. Minus times minus is plus. 4 times 4 is 16. 16 times 12. Let's do it on the calculator. So 16 times 12 is 192 divided by 2, and a is 12 times 12. So my y is equal to 8 plus or minus square root of 256 divided by 24, and square root of 256 is equal to 16. So my y is equal 8 plus or minus 16 divided by 24. So I know 8 plus 16 is equal to 24. So y1 is equal to 1, and y2 is equal 8 minus 16 divided by 24 is minus 8 divided by 24. So my y2 is equal minus 1 divided by 3. So if I want, now I replace y1 by x squared, because this is what we said here. Y is equal to y squared. So y1 is equal, so x squared is equal to 1, and x1 squared and x2 squared is equal to minus 1/3. So here I would have 3x squared plus 1 is equal to 0, and here I have x squared minus 1 is equal to 0. So I can replace my numerator here by x squared minus 1. So my numerator f second of x is equal x squared minus 1 times 3x squared plus 1, and all that divided by x squared minus 1 to the power of 4. I can simplify this and this, it becomes to the power of 3. So my f second of x would become 3x to the power of 2 plus 1 divided by x to the power of 2 minus 1 to the power of 3. So now I know that function outside minus 1 and plus 1, yeah, because we said here x can never be a plus or minus 1. It's always positive, because if x is not equal to if x is equal, let's say, to 2, 2 to the power 2 is 4, minus 1 is 3, 3 to the power 3 is 27, and this is always positive here. So my function is always positive outside when x is different minus 1 is different than between minus 1 and 1. It's always positive. So when it is always positive, the concativity is the upward concativity, and between minus 1 and 1 it is always negative, because if I take between minus 1 and 1, if I take 0, I would have 0 minus 1 is minus 1, minus 1 to the power of 3 is negative, positive divided by negative is negative. So between minus 1 and 1, it's always negative. So my concativity is downward concativity. So now if I want to draw my function, I have minus 1 and plus 1 vertical asymptote. I have a maximum between 0, x equals 0 and y equal to 0, and I have y equal to 2 as horizontal asymptote, and those are my vertical asymptote. So if I want to draw it, it becomes like this. Let's say this is minus 1 and this is plus 1, and those are asymptotes, and this is 2, it's horizontal asymptote, and I know this is a maximum here. So I know my and it is the concativity is downward between minus 1 and 1, so it goes up like that and goes down like that. And outside my minus 1 and 1, let's say if because I cannot have it like this. I cannot have it like this here, because I know it is from between plus 1 and plus infinity is this descending, and here it is ascending. This is ascending, so to be descending it should be like that. And my concativity is toward the up. Here my concativity is toward downward concativity, and this is upward concativity, so it is like that. And let me delete this. And again, between minus infinity and plus 1, it is ascending, and my concativity is upward, so it is like this. And that's how you draw your function. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.